Okay, so we started talking about this yesterday, but this is, what is this, lesson 7, I think. 7. We're going to talk about some of the properties that we need to talk about here. So, and then eventually, like I said, we'll go to the lab here down the road. Might be after the break, actually, probably by the looks of things, because we want to make sure we have enough time there. So we want to classify ionic compounds based on solubility, conductivity, pH, and state. Predict whether an ionic compound is relatively soluble in water or not. Okay, identifying ionic compounds, of course, we know it's cation and anion. It's positive and negative. Okay, so we already talked about that. Ionic compounds have very high melting points. Do you remember what structure they take on? What structure? Crystal lattice. Okay, so they take on a crystal lattice structure, which is really what? Summarize it for me. What's crystal lattice? Ionic compounds. And how do they attract each other? What holds them together? Sure. Yeah, opposites attract, right? Positive, negative, positive, negative, positive, negative, positive. That's what holds them together. Okay. So, like I said, salt, 800 degrees Celsius. That works out to be about 204. Or sorry, 800 degrees Celsius. Your oven, when you cook pizzas, at 400 Fahrenheit. Yes. Okay. Who does pizza? Pizza in the oven, 400 Fahrenheit. That's 200 Celsius. Okay. This is 800 Celsius. So it takes a lot of energy to melt ionic compounds. Not that much energy, well, not as much energy as it is to melt cheese on a pizza. Okay? All right. Solid liquid gas, we talked about. Yeah, okay. Even though ionic compounds hold together very well, that's true. They're always in solid form. But if you hammer them or break them, okay, did I draw a hammer yesterday? Oh yeah. I'll redraw it again today. There you go. Hammer. Tape. There we go. Okay. It's a hammer. I'll label it for you, hammer, if you want me to. That's how I know it's a hammer. Okay? If you hammer on them or stress them or bend them, like charges become aligned and they repel each other. It's like when you take magnets, they go together really easily. You turn them around, they don't go together very easily. Okay? They repel each other. They push away from each other. That's what happens there. Okay? And we talked about the crystal shape. Solubility. We talked about solutes and solvents yesterday. Yes? Here's the thing, okay? And you're going to need your periodic tables out, guys. All ionic compounds are soluble to different degrees. In other words, they break up in water to a different degree, okay? Some break up very well. Some don't break up particularly well, okay? And this is kind of what happens is when you put them into water, water's polar, and I showed you guys yesterday in the lab, yes? That water's polar, it's got a charge to it, it's got a negative end and a positive end. And when the negative end becomes close to the positive ion, it attracts it. And the positive end of water and the negative ion are also attracted, so it helps pull the ionic compound apart. Now that happens really easily in some cases, okay? And if you flip over your periodic table, guys, to this side here, I'll show you which ones happens very easily with, okay? Flip it over, periodic table, quickly. Here's the solubility chart up here, guys. Top right, I guess, for you guys. Okay? Solubility chart. The ones, basically the ionic compounds that would be considered to be this middle row here kind of thing, so we'll talk about how to figure that out. Those are the ones that break up very, very easily. The bottom part are the ones that don't break up particularly easily. Okay? So that's kind of what we're going to use to test solubility. All right, we'll get back to that in a second here. All right, conductivity in a solution. Solutions that contain ionic compounds are good conductors of electricity. Okay, good conductors of electricity. The greater the concentration of the ions is, the more compound you put into there, the more conductive it becomes. Okay? So the greater the concentration of the ions, the more conductive the solution is. Solutions of ionic compounds are excellent electrolytes. What does electrolytes mean? Well, I guess it's up there, isn't it? What's electrolyte? Read it off the board then. Fine. What's an electrolyte? A solution that conduct electricity. Okay? When you drink Gatorade, yes? Gatorade's supposed to be electrolytes, yes? Yeah, it has that in there, okay? It is basically, if you want to know, okay, Gatorade is potassium. Is potassium, does that make sense? Is potassium an electrolyte? Potassium's a what? Does potassium have a 1+ charge, or is it technically neutral? I guess it depends, doesn't it? This says potassium. Does potassium have a charge? Look over there, guys. If K has a 1+ charge, do you think that K has a 1+ charge? It can have, but let me ask you this. Okay, we've talked about this before, guys, so look, this is a big deal in chemistry. I'm just going to shortcut this here. What's potassium there? 19? 19 protons. What's the weight of potassium? 39. Okay. So 20 neutrons, yes? Good. And how many electrons would potassium have? Potassium, yep. 19. Okay. So then you'd have 19 electrons out here, yes? So let me ask you again. Does potassium have a 1+ charge? No. Is potassium neutral? Okay. So when it says potassium here, okay, is that really potassium? Because, guys, if it was really potassium, potassium's pretty unstable. If you put potassium into water, which is what Gatorade is made out of, it will actually have a chemical reaction, a very violent one, okay? And it would not be good. You would not drink that because it would make potassium hydroxide, which is a base. And you would get, well, you would not feel very well, okay? So what you have to understand here, guys, is this, okay? They tell you it's potassium because when I say potassium, who eats bananas? Right? Bananas have what? Potassium, right? Okay, but listen, it's not that potassium, okay? There's a big difference between potassium and potassium ions, okay? Now, I'll pretty much guarantee you, in Gatorade, there is potassium ions, okay? The problem is right now, what should your next question be? If I said, hey, that's got potassium. They didn't put ions in there because most people wouldn't understand potassium ions. They'd be like, what's that? What's an ion, right? You guys are science 10, so you know what an ion is. It's an atom with a charge. But what happens if I said, hey, it's got potassium ions? What should your next question be to me? What does that mean? What does K+ mean? We talked about earlier on the quiz. K+ means it's what? Come on, guys. Huh? Positive. How does it get a +1 charge? It's lost an electron. Your next question should be what? What? Where did it go? Right? Do you not think? If potassium loses an electron, right? Just go to your home, electron. Why won't you go to your home? Where did it go? It's got to go somewhere. So what are they missing? They're missing, probably my guess would be, and I could be wrong because I don't know the secret formula of Gatorade. They probably wouldn't tell me that. But I'm probably missing that, for example, potassium chloride. Okay? Or maybe it's potassium, it's probably not, but it's maybe potassium fluoride, or potassium bromide, or potassium iodide. I don't know. Okay? Probably not potassium iodide, but whatever. I don't know. Okay? So there's a big difference between potassium and potassium ions. Okay? Potassium ions means it's lost an electron. That electron has to go somewhere. So when they say potassium, they're not talking about potassium, because that'd be a very violent reaction, and you would not drink that, because there's a chance you would probably die. A good chance, if it was strong enough, because it would make potassium hydroxide. That's complicated. Don't worry about it yet. We'll talk about that down the road. Okay? They're talking about potassium ions. What they're not telling you is what the negative ion is, because they don't think that you're smart enough to figure that out. Okay? So they just say potassium because potassium, but it's really probably potassium ions. Okay? They would not take a chunk of potassium and dump it in there. That's a bad decision. I'll show you if you want. When we go to the lab, you remind me. I'll show you what happens when you put potassium in water. Okay? It's not pleasant. No, we cannot go now. Okay? So let's go back to here. Solutions of ionic compounds that conduct that have electrolytes, that are ions, basically ions. They can conduct electricity. If a solution does not contain ions, for example, sugar. Sugar is not an ionic compound. It is a molecular compound. If you dump sugar into water, it will not conduct electricity. Okay? Ionic compounds in water, they do. Okay? The dissolved ions are free to move and carry a charge. Now, what we have to remember is this. Listen. Ionic compounds do not create electricity by themselves. Okay, that's not what we're talking about. If you take salt, sodium chloride, guys, and you put it into water, you cannot run your house, electricity. You cannot turn the lights on by sticking 2 wires in the pot, okay, and turning all the lights on in your house and watching TV and stuff like that. If that was the case, we'd have a lot of problems solved, okay? That's not what it means, okay? Because everyone would be buying salt, putting it in water, putting 2 wires in, and then turning all the lights on their house and be like, look, I'm powering my house from sodium chloride and water. No, that's not what it means. What it means is, if I put a current through the solution, the current would make a complete circuit, okay, and we're going to do this. It would make a complete circuit, and it might light up some light bulbs. Electricity would pass through the solution. Yes, that's conductivity, okay? And it does that because there's positive and negative ions in there, opposites, okay, like batteries. Think about batteries, okay? So, it can carry a charge, ionic compounds, conductivity in solution. Okay. Solutions containing ionic compounds are good conductors of electricity. I think we already have this, don't we? Yeah, got that. Some ionic compounds are very soluble in water. Others are not very soluble. We call them slightly soluble. If a compound is only slightly soluble, a precipitate is formed. That means a new solid is formed. And you would see that, okay? It's a solid with low solubility that forms a solution. To determine if an ionic compound is soluble, we use the solubility chart, okay? So demonstration, we'll do that on maybe tomorrow, okay, after your quiz here. Here's what we're going to do. So I want you guys to find your periodic tables. So, listen. You will find the negative ion across the top, okay? you will look for the cation in the column below the anion. Okay? So if you look here, here's the negative ones. They'll either be in here or in here listed. Okay? So you have two options. Okay? Let me we'll do some together here. Just wait. Okay? This row is called very soluble. So this row right here will not form precipitates. Okay? Not form precipitates. This row down here will form precipitates. Okay? So the bottom row is the precipitates. This row is not the precipitates. It's very soluble, we'd say. Okay? Now, like I said, we will look at some examples. Okay? So here we go. By the way, if the subscript, if it's not very solid, if it's bottom row, we would put an S behind it to represent solid, precipitate. Okay? If it's this row right here, we put an AQ behind it to represent that it's very soluble, aqueous, very soluble. Okay? All right? So, we'll go with these. Aluminum sulfate will be our first one. So follow with me, guys, and let's do this together. Okay? What do we look for first? Aluminum sulfate. What do we look for first? What? Yeah, it is ionic. What do we look for first? Look back at the rules that we just talked about, guys. We look for what ion first? The negative ion, yes? Okay? So we're going to find the negative ion. Which one's the negative ion? Aluminum or sulfate? Sulfate, okay? By the way, aluminum's a 3+, sulfate's a 2-, yes? Find that across the top. Find it, no, on the back. Don't worry about the front. Find it across the top. Where do you see SO4 2-? You find it? Okay, it's right here, isn't it? Kind of in the middle, right there. Yes? Okay, find it. Where is aluminum 3+, according to this? So you're going to look down. So look down. You see the word most? Okay, yes? You following me here? Look. See the word most? And then you see a list of 1, 2, there's calcium, strontium, barium, silver, HG, Ra. Yes? Okay. So where is aluminum in that list? Do you see it in the bottom? No. So by default, they're saying if it's not there, it's here. Okay? It's in the most category. Yes? Okay. Do you see it on the bottom, Al3+? Is it down here somewhere? Do you see Al3+ down here? I don't. Okay. I see calcium, strontium, barium. I don't see Al3+ there. So that must mean it's in the most category. Basically, it's saying here's the ions that are solids. Here's the ions. Everything else is not a solid. Okay? So this would be in the most category. And if I was to write this out, I would put down behind AQ. Okay? AQ. Or I'd say aluminum sulfate. Let's do a little practice. Swap and drop. 2, 3, and I'd put a Q behind it because it's very soluble. Look, right here. Very soluble. This is the very soluble row for the metals. This is the not very soluble row for the metals. Okay? A Q and S. All right? A Q and S. But we always start with the negative ion across the top first. Yes. Yeah. Okay? Now, okay. Good. Let's do the next one here. Calcium oxalate. Calcium is a 2+. Okay? Look on the periodic table, it tells you that. Calcium is a 2+. It's an ionic compound, guys. Oxalate looks like this. That's in the top left. That's the periodic polyatomic ion list there. Oxalate. Okay? Which do you look for first? Negative one, yes? So find this across the top. Find it? Okay? It's over beside here. It's the second last one, yes? There's actually two there, yeah? So it's there, yes? Follow me so far. Where's Ca2 plus? Where do you find it? Is it up here? Do you see Ca2 plus up here? Or is it down in the most category? Well, it's not up here, so I guess by default, it must be down here. Yes? Okay. So look, if it's down here, this is the not really soluble row, right? So we say that's a solid down there, slightly soluble solid. So I would say CaOOCCOO. And then at the end here, I'd put an S because that's in the bottom row. Okay? Good? Question? Yeah. Yep, no, down. So there's OOCCOO. Calcium, I don't see calcium here anywhere. So it's there. So because it's there, that's the solid row. This is the solid row, this is the aqueous row. Okay, good, yep. Yeah. Yeah. Yes. Which means it's going to form basically a precipitate or a solid. Yeah. Yeah, and then the positive. Yes. Okay, let's look at the next one here. Iron 2 fluoride. Iron 2 fluoride. Now, you'll notice, guys, there's a common theme here. Okay, and in fact, it says this right here. Look, ionic compounds. Okay, that's what we're talking about. These are ionic compounds. If it's molecular, okay, that's not really a solubility chart per se. Okay, so these are all ionic. That's the key here. Look, iron 2 fluoride. Yes? Iron 2 fluoride. We look for what first? F minus, right? Find F minus across the top. Found it? Okay. It's right here, yes? F minus. Okay. F minus. Where do you see Fe2 plus? Okay. Is it in most? Or is it one of the ones listed at the bottom here somewhere? It is listed in the bottom, yes? So once again, Fe2 plus is in the bottom with F minus. So that must mean it's going to be bottom row, solid, yes? So we would say, okay, Fe is a 2 plus. F minus comes over down, 2 plus comes over and down. That's iron 2 fluoride. Swap and drop. We said it's in the bottom row, so we put an S there. Okay. Good. Sodium hydroxide. Yep. I'm not sure what you're asking me. Let me do the last one here, and then we'll see. Okay. Okay, last one. Okay. We're doing good. Here we go. Look, sodium hydroxide. Sodium is a 1 plus. Hydroxide is that. Okay. If you don't know what hydroxide is, once again, you know, we're going to go back to here, and you'd look up here, right? Hydroxide, OH1 minus. Okay. So we look for what first again? Negative. Okay. So we find OH minus. Oh, there it is, right in the very last column. Yes. OH minus. Where is Na1 plus? Na1 plus. Is it in the top? Or is it in the most? Okay. So listen, once again, I want you to consider this closely. Okay. Where is, I'll ask again, and don't change your answer just because. Think about this. Where is Na1 plus? Is it group 1 ions or NH4 plus, or is it in the most category? Na plus. Look on the chart. Look on the periodic table, guys. Where's Na1 plus? Is it in what we call Is that group 1? Is it group 1? Yeah. Yeah, it's a group 1 ion, guys. Isn't it? It's in group 1. That's the groups. Up and down. We talked about that. Up and down. Is Na1 plus in group 1? Yep. So where's group 1? It's up here. Yes? So don't be like all like, oh, it's in the, I don't see it listed there, so it must be in the bottom part. We have to also take into consideration maybe groups that they belong to or the exceptions. So listen. Do you agree? Look, here's OH minus once again. Na1 plus would fit into right here, group 1. Yes? Look, Na1 plus, Na is in group 1. So is that very soluble, or is that a precipitate solid? Very soluble. So I'm going to swap and drop 1 and 1, and I would put AQ behind it because it's very soluble. Got it? You got to be paying attention to periodic table back and forth and solubility chart. Yes? Okay. Question, anyone? What was your question? I don't know if I understood you. Oh, like that stuff. Yeah. So sulfate is there, right? So I always start with the negative ion. What if you can't find what now? So if it's not one of these, then it's in the most category. Okay, so basically it kind of goes by, I don't want to say default, but if it's not one of the ones listed, then it's got to be in the other part. Yeah. Yeah. All right. Homework. You guys got some homework to do, I guess, eh? Okay, so you need to fill that in. You're going to have to go through and make yourself those notes, guys. Please do that tonight. I know you got to test tomorrow too. I get that. You got about 15, 20 minutes left. But fill in the notes that we talked about. Go back through the notes again in Google Classroom, because there will be some notes that you need to fill in at the top part again, and maybe some examples that you may want to go through. Okay, so fill in those notes, because that's what you're going to use to help you study. And then you got some homework questions there as well on solubility. Okay, and maybe a few other things there as well. So make sure you get that done tonight.